So isn't it an interesting time for this industry? This is my third year at the AWE, and each year I'm just fascinated with the advances that are made from the previous year. It's really, I've really enjoyed seeing how the technology has progressed. So a little bit about Lockheed. It's a large employee base, over 120,000, a large number of engineers, almost 600 facilities across the US, and then also internationally. Would you believe that we hire 5% of all of the engineering students from all of the colleges and universities across America? It's about 4,000 students per year who graduate with an engineering degree. 5% of those are hired by Lockheed. So there's a great opportunity when you have this type of engineering work and the volume to use a tool like augmented reality and wearables. There's our business areas. We have 5 business areas. Christy just spoke from aeronautics. I work with Space Systems Company. So the question is, why? Why AR and wearables within Lockheed Martin Space or within Lockheed? When you look at how AR and wearables can support our efforts, it's really not about the technology or the hardware. It's about the value of information and the need for information within our manufacturing workforce. We also are looking at AR and wearables for other purposes, but I'll speak just to the manufacturing topics today. So, of course, our expertise spans broad regions, so remote assistance is very useful, but remote assistance is also very useful when it's 2 people at the same site, maybe in different buildings, or even in the same building. We'll talk a little bit about that. We develop very small numbers. We may build only a couple of a type of satellite. And in some cases, we'll build a subsystem, and then there may be a significant amount of time before we build the next iteration of that subsystem. By that time, engineers have gone and experts have gone to work on new projects. We may have new technicians, new engineers in that manufacturing process. So tools that can provide very clear and concise instructions become very valuable. And then we also deal with very high-value hardware. This puts an exclamation point on the need for tools that can help with error mitigation. And then we also think of the manufacturing process as segments that break apart nicely. We think of the chocolate orange that we can split into very nice, clean pieces. When we look at the information flow spans across all of these segments, and tools that help us optimize that information flow become very valuable. We'll be able to measure that over time to see how that improves the process. At Lockheed, we refer to this as the Digital Tapestry, and there's a significant effort in taking what Christy mentioned, the legacy paper version, into a digital environment where we can use information to our advantage. And we also think of AR and wearables as tools to allow us to access information, but we see many other opportunities. There are great opportunities in capturing and creating information to use later for that purpose, and then also to communicate the data. And then, of course, there's commanding all of that information. With the tools that we have, the keyboards, the mouse, the tablets, we have a specific type of input mechanisms. When we go to something like a wearable, we end up with a need for better ways to command that information. And so we're seeing some very creative solutions that can allow us to do that. There's a few areas where we want to see or need to see new creative ways to do that. Now here's an example. How many have seen the augmented reality work instructions? Yeah, it's a pretty popular topic. So this one should be familiar. so I'll use it as an example for how, one of the ways that we look at information. So in this case, we had a 38-step work instruction. This is for a hinge assembly. We built up that work instruction in augmented reality. What's important also is how we look at how this improves the information flow. So is anyone here familiar with the OODA loop? The OODA loop was designed or developed by an Air Force pilot long ago. And they were looking at ways to optimize their missions. And they broke it down into the ability to observe, to orient, and decide and act. So if you think about it, if you have better observations that get the point across more clearly, it allows you to go through that orientation process to understand that information, which leads to more effective decisions and actions. And there's also a time element to the OODA loop in mission analysis. We can take that same approach and apply it to a manufacturing process. And we're not the first ones to do this. It's been done quite a bit, even by the auto industry, by Toyota. You can get to a point where you can see how these tools can really influence this OODA loop process. So it's also important in being able to build these augmented reality work instructions to have tools that allow you to do the development part of this quickly. In this case, we had a teaching fellow joining us for a summer project, and he had 1 week left when we started this effort. He had 1 day of training, and he was able to build this 38-step work instruction in 15 hours. That's about 30 minutes per step, and that's his first time through this process. We were fascinated that he was able to do that quickly. So when we look at building these, we often find that it takes less time to build the augmented reality version than the text and picture version. It's kind of a picture is worth 1,000 words, so what is augmented reality worth? You can get the point across much more quickly with fewer words. Okay. And then capturing and creating data, it's important to be able to relay information from shift to shift. It's important to be able to capture information that would be very valuable later in fault analysis. It can really accelerate that effort if you have good tools with good data. And this would also benefit the orientation, the observations and orientation in those later phases. We also see great potential in being able to capture data for verification purposes. And then communication. Remote assistance is a very interesting tool. We think of it as preventing travel or preventing the need for travel, but it's also within our environments. You see here, up on the platform, there's a person performing a function. They're in clean room suits. If they need assistance from someone elsewhere, that person either has to carve out the time to come over, get into the clean room gear, assist for a little bit, get out of the clean room gear, go back to their efforts. So with that amount of time, they usually have to wait until they have a block of time available. That slows down the production process. And for us, that's very expensive. So if we have tools that are effective, where they can communicate from the meeting that they're in or the office, it can speed up this process. One thing that we've seen, it's not just that it's a better approach than other remote tools that are available today. The remote tools that are available, or yesterday, aren't effective enough, so they choose not to go that route. It's not a comparison of those tools versus the tools that are there today. It's a matter of they wouldn't use the tools in the past because they weren't effective. Now the tools are becoming effective where they can use this approach. So we're seeing very exciting things in this area as well. And then a favorite topic is the ability to command the data. I think this is one of my favorites because we're seeing very creative solutions in this area. It's also one of the most challenging. When you look at taking something like a tablet and the information that we get from a tablet and then going to a wearable. It's a huge shift. And one of the goals is to be hands-free. So all of our input mechanisms with tablets and computers are not hands-free. It creates a significant need for these hands-free tools. Another thing is that within our environments, so many of our programs don't allow Bluetooth or Wi-Fi. And so when you have a handheld Bluetooth or Wi-Fi device or sensors that are Bluetooth or Wi-Fi, that creates another challenge because we either have to find a solution to have them in the area, very creative solutions, or we need something that goes beyond that Bluetooth Wi-Fi capability. So if it can be built into the device, that's a huge advantage for us. It needs to be very intuitive. We're okay with the learning curve, but we prefer not to have to go that route if we don't have to. So if there's ways to command the data where it's very intuitive, you don't have to spend training dollar, that's very valuable. And then our environments. We typically start off with thinking about voice recognition. Within our environments, voice recognition works a very small percentage of the time. If it's very quiet or very loud, that causes problems with voice recognition. There's also times where we need to be able to type character string entry, whether it's a red line, part numbers. In that case, voice recognition doesn't work the best. We haven't found a solution yet for this one, a replacement for typing. So that's one that we're focused on finding a solution.